Hello everyone, welcome to the next session. In this session, we are going to discuss about the timer. The timer is the most important point in the industrial automation because as and when you are going to discuss about and think about the industrial automation, so might be in your mind sometime you are and somewhere you have already heard the manufacturing process. So in the manufacturing process, in the sequence control process, in the process control, we have to perform the operations with some timer delay. So as and when we are going to provide the delayed operation to our output devices, in that case we require the timer. Previously we were using the timers in hardware form because at that time we don't have such a controller. Uh, we didn't have the such types of softwares as well. That is the reason nowadays we are using the controllers like a PLC. The PLC has overcome all these limitations already. So we don't need to use the timers in hardware form nowadays if we are using the PLC as a controller. Now, if you are using the PLC as a controller, the PLC is already having the timer in its software. So basically, there are three different types of timers which we are going to use in this Alumbradi PLC. So here you can see the first one is the on delay timer, second one is the off delay timer, and the third one is the retentive on delay timer. So I have mentioned the short form of these timers also because when you are going to use all this timer in software, there should not be the complete and you are not getting the word on delay timer, off delay timer directly. So you will get the TON means the on delay timer, TOF means the off delay timer, and RTO means the retentive on delay timer. Now coming toward the memory part means if you are using the timer in your program, how much memory or how many memory it will consume and it will require. So basically the single timer require a 3-word memory. 3-word means what? The 48 bit, because the 1 word means what? 16 bits. Means as in when you are going to think about the timer, so definitely you should be aware about the memory which is occupied by the timer as well. So there are some alternative. We cannot say the alternative, but we can reduce the number of timers by using some additional instructions like a compare instruction. In upcoming session, I will try to cover the compare instructions so that instead of using the 25 timers, we can use the only one timer for the same project. Now here you can see here I have mentioned some preset, accumulator, and the status. So these are the very important points which are available in the timer. So basically the preset means what? The preset is nothing but the timer delay. Basically, for example, if you have to turn on the motor for 20 seconds or for the 25 seconds, so delay doesn't matter, delay may be anything. So that 25 seconds, that 10 seconds, nothing but the preset value. And that particular preset value occupied 1 word memory. Similarly, here you can see the accumulator. Before coming toward the accumulator, so let us discuss some more point about the preset. So when you are using the timer, so you must be aware about some important points which are related to the timers. So that is nothing but the total delay which we can provide for the single timer. Second, can we provide the floating numbers as a delay to the timer? So all this question will arise to you while designing and while putting the timer delay in the programming. So obviously we cannot able to put the floating number in the timer. The floating number means what? For example, 12.5, 30.5. So these are the floating numbers. Means the floating numbers doesn't suppose the timer. But we know that every time for executing any output operation for the particular delay, there should not be an integer number. So why I'm telling you about the integer number. The integer number means what? The number which consists of positive as well as negative numbers. Basically, our timer supports only positive integer numbers, means 1, 2, 3, 4, 5, 6, 7, 8, up to 32767. So in order to fulfill the requirement of our timer, the developer has given some time-based number. So before coming to the time-based number, let us finish this preset, then I will give you the detailed examples which is related to the time-based. The first important thing which you have to remember, that is nothing but timer supports integer numbers only, specifically positive integer numbers only, right? It doesn't support the negative integer numbers, doesn't support the floating numbers, right? Okay, now coming to the accumulator. Accumulator also occupied the one word memory. Accumulator means what? It's count and store the preset value. For example, we have provided the preset value of 10 seconds. The role of accumulator is to count it. It will start counting the delay from 0, 1, 2, 3 up to the 10 seconds. This is just for the example. Okay. It also required one word memory. Now the next status bit. The status bit also occupied the one word memory. So what exactly the meaning of status bit and why we require the status bit in the timer? Basically, the status bit is the most important part in the timer, because when you are using the timer and if you want to provide the delay, okay, of the timer to our outputs, so that is possible only by using the status bit. So basically there are three different status bits. The first one is the enable, the second TT bit, and the third one is the done bit. Okay, TT means what? The timer time bit. Now let us understand the meaning of this enable bit, timer time bit, and the done bit. Basically, the enable bit is same as the input switch, same as the start switch. Means when you are pressing the start switch, accordingly you will get the indication from the enable bit, and when you are releasing it and when you stop it, the enable bit doesn't respond. Okay, means the enable bit is completely depending upon the current state of the start switch or the input switch. Simply, when the state of input switch is 1, then the state of enable bit is also the 1. When the state of input switch is 0, 0 means to see low, then at the same time the state of enable bit is also low. Now coming toward the TT bit. TT bit means our timer time bit. So let us take the example. If you want to turn on the motor for 25 seconds, so how to execute this operation? So in order to accomplish this operation, we require the TT bit, means the timer time bit, because the role of timer time bit or the TT bit is to turn on the field output device for the particular time delay. Means it will be turned on the motor for 25 seconds, and after that your TT bit will be turned off. Now coming toward the done bit. Done bit means what? For example, if you want to turn on the motor after the completion of 10 seconds, so at that time we require the done bit. Now coming towards the addressing of the timer. So here the most important part, in the Allen Bradley PLC you will get total 256 timers. Here I am talking about the SLC 500 PLC, means the modular type PLC. Basically, as per the selection of controller, you will get the different timers. Means if you have selected the Micrologix as a controller, so definitely you will get some differences in the timer as well. But the addresses will be same, logic will be same, but the difference is only of the controller, the input output addresses and some limitations. Now here we have 256 timer, and the range of these timers are 0 to 255. Here addresses are given T4:0, T4:1, and up to T4:255. T means time mode, 4 means data file numbers. In the programming I will show you the location of the timer data file. Means it comes at the 4th place. That is the reason the developer has designed the address of timer like this, T4:0 means what? This is the first number timer, because in Allen Bradley PLC we are starting the addresses from 0 only. We have already discussed in the previous sessions. You can take the reference of the previous session so that you will get to know the concept of the zero, why we are starting the addresses of Allen Bradley PLC from zero. Okay, it's all these things are completely depending upon the developer. If you are a developer, you can suggest the address as per your requirement and as per your choice. Now coming toward the preset value, for calculating the preset value, basically if the given value and the given timer delay is the floating number, so we cannot put the floating number directly in our timer block. So let us take the example here. The timer delay is given 25.6 seconds, and now in our timer block you will get three different time-based values. The first one is 1.0, second one 0.01, and third one 0.001. So we just need to remove that point. Okay, 25.6. So here you can see we have a formula: preset value equals to timer delay upon time-based value. So if you are selecting the time-based value 1, so we will get the same value 25.6 seconds. But if you are selecting the time-based value second, means 0.01, then we can able to convert that floating number into the integer number. Now here you can see, so we have calculated the answer, that is 2560 seconds. But to make sure that after putting this preset value as a timer delay, your time-based value should be changed. Okay, that should be 0.01. Now here I have mentioned the integer range. In the Allen Bradley PLC, we have to follow this integer range throughout the programming. -22768 to +22767. In the Allen Bradley PLC, you can able to provide the maximum timer delay, that is nothing but 32767 seconds only. Now we cannot provide the negative integer number, so that is the reason we have to start the timer delay from 0 and ends to the 32767 seconds. Now this is all about the timer. So rest of the part we will see into the next session. Thank you.